There's a lot of different styles of carabiners out there. There's oval carabiners, D carabiners, pear-shaped carabiners, and each of these can come in aluminum and steel. And what we're going to talk about in this section is exactly what are the appropriate uses of carabiners in a slackline system, what are the pros and cons, and what are some of the common failure modes of these different forms of carabiners. Okay, so we're going to start off with aluminum versus steel. There's a big argument as to aluminum is more appropriate, steel is more appropriate, and honestly, neither of those are actually applicable because we need to actually understand how carabiners are tested, how they're loaded, and what their ratings are about before we even get into that argument. So in my hand here, I have a standard aluminum carabiner. This is an oval style carabiner, and the way these things are tested is they're actually tested on 2 steel pins pulling this direction. Okay, this is how they're tested and this is how they're rated. If I pick up a more common D-shaped carabiner, also this is how they're tested, this is how they're rated. Okay, this is the configuration that all carabiners are supposed to be used in or set up in. Okay, when we start using carabiners for line lockers, for connecting span sets, we start getting into this territory of tri-loading. Okay, and what tri-loading is it's essentially taking the carabiner and instead of pulling pin to pin in this orientation, we're actually putting a load going down this direction and then 2 more loads going this way and this way. Okay, that moves the load sharing from the spine typically. We can use that for D-beaner, might be a better example. Most of the load is set onto the spine to moving the load to the gate, and that's not really how they're supposed to be used. That's one of the most common ways to have carabiners fail below their stated braking strengths. Okay, so it's really important to remember when you're using carabiners in general, but also in regards to slackline use. Okay, most carabiners, if not all carabiners that are climbing or used for climbing or used for industrial purposes, have a load rating stamped on the side of it. These ones say 22 kilonewtons when loaded in the proper orientation. Okay, so we'll consider that to be our minimum braking strength, or MBS. If we want to use the same safety factor and working load limits that we talked about in the previous videos, we can apply a 5-to-1 safety factor to this and reduce this to a 1/5 to bring it into a safe working load. Okay, that's important to understand because that concept just always comes back and back and back whenever we're talking about rigging. Okay. When we get into the different styles of carabiners, typically we want to understand that any style of carabiner, whether it's steel, aluminum, D-beaner, pear-beaner, when brought under sustained dynamic cyclic loading, the material becomes weaker and it becomes fatigued. So you might actually, if you're using it in such a way, you might actually be decreasing that stated minimum braking strength over time because you're fatiguing the material. One way that you can test if you've brought your carabiner or your connector to a too high of a load is if the gate stops opening or it's shifted to one side or it's difficult to open. That typically means that you've overloaded the carabiner, the connector, and you should probably retire it. Okay, there's been significant testing on strengths of carabiners used in the climbing world and also industrial rigging, but not so much specifically applied to slacklining. So again, we're using common knowledge or stuff that we've learned over time, to provide you material with and to learn from. Okay. We can also talk about failure modes. What are common failure modes for aluminum versus steel carabiners? Aluminum carabiners typically won't deform much until they fail. Okay. There might be a slight deformation, maybe the gate will become difficult to open, but you're not going to get a huge strain or big elongation of the spine before it fails. It's pretty much going to fail. Steel, on the other hand, might take a little bit longer. It might deform a little bit longer before it actually gets to that yield point. Okay, so when using carabiners, it's probably, especially in burly, life-depending or life-saving situations, steel is probably a better way to go. You can also use these ovals or steel locking oval carabiners even better for your primitive systems. Okay, then you really get into the game of using strong connectors, using strong equipment, and really reducing that possibility or that opportunity for failure. Okay, and to be quite frank, carabiners are essentially, getting phased out of the slackline scene because there's more research coming to light. There's other connectors that are more appropriate. So really, when we talk about carabiner use, honestly, like oval carabiners are the most applicable because they're used in our primitive tensioning systems. They're also used in our long line tensioning systems for the multiplier. That's really the only safe and common practice or the common situation to use this style of carabiner. Another mode of thinking is when we get into highlining, using carabiners for temporary tensioning systems. Like if you're soft pointing, essentially removing the pulley system off of the slackline after you've tensioned it. That, in my opinion, would be an appropriate use for a carabiner because it's being loaded for a short period of time. It's not going through cyclic load cycles, and it's only being used for a temporary connection, and then it's being removed. So it's not going to be in a lifeline system. Okay. So carabiners, there's a lot of them out there. We really want to make sure that you understand that carabiners, honestly, they're being phased out right now and being replaced by quick links and shackles because they're bomber. They have sufficiently rated strength characteristics and are meant for sustained loading, right? So now that we've covered carabiners, we can't wait to get into more of the material in the next videos.